Captain Jake Morrison stood on the bridge of the USS Meridian and watched the massive structure grow larger on the main screen. The thing was huge beyond belief, bigger than most moons he had seen in his 20 years of space travel. The Velth Empire called it Nexus Prime, and they claimed it was the greatest engineering achievement in the known galaxy. "Captain, we are receiving a transmission from the station," said Danny Brooks from his position at the communications console. Fingers moved quickly over the controls as alien symbols appeared on his screen. "Put it through, Danny," Jake replied. He straightened his uniform jacket and prepared to meet the beings who had built this incredible structure. The main screen flickered and changed to show a tall crystalline figure. The alien's body looked like it was made of living glass that shifted and changed color as it moved. When it spoke, its voice sounded like wind chimes in a gentle breeze. "Welcome, humans of the vessel Meridian. I am Zix Thera, lead engineer of Nexus Prime. We have been expecting you. Your species has recently joined the galactic community and we wish to show you the proper way to build in space." Jake nodded politely. "Thank you for the invitation, Zix Thera. We are honored to visit your station. You will dock at Bay 7. Bring your engineering staff. They must see how real civilization builds its structures." The transmission ended and Jake turned to his crew. Chief Engineer Lisa Rodriguez stood near the engineering station, her dark eyes studying the readings on her screen. She had been with Jake for 5 years, and he trusted her judgment more than anyone else on the ship. "What do you think, Lisa?" he asked. "The power readings are incredible, Captain. Whatever they are using for energy, it is beyond anything we have seen before, but—" She paused and looked at the screen again. Something seemed strange about the power distribution patterns. Navigation Officer Ben Carter looked up from his console. "The station is massive, but it seems to be using a lot more energy than it should need for its size. Our computer models suggest it should be much more efficient." Science Officer Amy Watson nodded in agreement. "The quantum signatures are unusual too. It is like the entire structure is alive somehow." An hour later, Jake and his senior staff walked through the docking bay of Nexus Prime. The walls around them pulsed with soft light that seemed to flow like liquid through crystal veins. Everything was smooth and curved, with no sharp angles or straight lines anywhere. Zix Thera met them at the airlock. Up close, the alien was even more impressive. Its crystalline body stood nearly 8 feet tall and seemed to contain swirling galaxies of light within its transparent form. "Come," Zix Thera said. "You must see the heart of our creation." They walked through corridors that seemed to grow and change as they moved. The walls were warm to the touch, and Lisa noticed they actually flexed slightly when she pressed against them. "Your station is alive," Amy observed. "Of course," Zix Thera replied. "All proper engineering uses biocrystalline technology. We grow our structures rather than build them with dead materials. This is the way of all advanced civilizations." They entered a vast chamber at the center of the station. The room was filled with towering crystal formations that pulsed with energy. Streams of light flowed between them like rivers of pure power. "This is our primary energy matrix," Zix Thera explained. "Each crystal is a living entity that processes quantum energy and distributes it throughout the station. They think and adapt, making the entire system more efficient over time." Ben studied the flowing patterns of light. "How do you control it?" "We do not control it. We guide it. The crystals know what is needed and provide it. This is far superior to your primitive mechanical systems that require constant manual adjustment." Lisa walked closer to one of the massive crystals. She pulled out her scanner and took readings. The numbers made her frown. "Zix Thera, may I ask why the crystals are producing so much excess heat?" "Heat is natural. Living systems create heat as they work. But this much heat means wasted energy. In our mechanical systems, we use cooling systems and heat exchangers to capture that energy and use it elsewhere." Zix Thera's crystalline form shifted colors, showing what might have been confusion. "Your systems are dead metal and circuits. They cannot think or adapt. They are crude and wasteful." Amy pointed her scanner at another crystal formation. "These bioprocessors seem to be working very hard to solve simple mathematical problems. Our digital computers could handle these calculations much faster." "Speed is not everything," Zix Thera replied. "Our systems are elegant and beautiful. They grow and evolve. Your machines are static and lifeless." Jake listened to the exchange with growing interest. His crew was being polite, but he could see they were not impressed by what they were seeing. The alien technology was certainly advanced, but it seemed to create problems that human engineering had solved centuries ago. They spent the next 3 hours touring different sections of the station. Everywhere they went, they saw the same pattern: beautiful living systems that were incredibly complex but seemed to waste enormous amounts of energy and time on simple tasks. As they returned to their ship, Lisa shook her head. Captain, their technology is amazing, but it is not practical. Those living crystals spend so much energy just staying alive that they have little left for actual work. And they adapt so slowly, Ben added. When conditions change, it takes their biosystems hours to adjust. Our mechanical systems would respond instantly. Jake nodded thoughtfully. He had seen something important today, but he was not sure what it meant yet. Back aboard the Meridian, the senior staff gathered in the main conference room. Jake sat at the head of the table while his officers shared their thoughts about what they had seen on Nexus Prime. Lisa spread her scanner readings across the table display. Captain, I have been thinking about their energy systems. The Valtharians are using 10 times more power than they need for the same tasks we could do with simple mechanical systems. But their technology is alive, Amy pointed out. It can repair itself and adapt to new situations. That is true, Lisa agreed. But look at the cost. Those crystals spend most of their energy just maintaining themselves. In the time it takes one of their bioprocessors to solve a problem, our computers could solve 100 similar problems. Ben leaned forward. And what happens when their living systems get sick or decide to evolve in a direction they do not want? At least our machines do what we tell them to do. Jake nodded slowly. So you are saying their advanced technology might not be better than our primitive methods? I would not call our methods primitive, Lisa said with a small smile. Different maybe, but not primitive. We use mechanical systems because they work reliably and efficiently. Danny looked up from his communication console. Captain, I am receiving a priority distress signal from the Kepler 442 system. It is coming through multiple alien communication networks. Put it on the main screen, Jake ordered. The display showed a blue-green planet surrounded by several alien ships. The voice that came through the speakers was translated by the ship's computer into English. This is Emergency Coordinator Vexmel of the Kepler 442 Defense Fleet. We have a massive asteroid on collision course with our home world. The impact will occur in 72 hours. All available ships with advanced engineering capabilities are requested to assist immediately. Jake looked at his officers. How far is Kepler 442? 18 hours at maximum warp. Ben replied quickly. What kind of asteroid are we talking about? Amy asked as she pulled up stellar charts on her console. Danny worked his controls and additional information appeared on the screen. The object is approximately 50 kilometers in diameter and composed of exotic matter. Current trajectory will result in total planetary destruction. Lisa studied the data. 50 kilometers of exotic matter. That is going to be very difficult to move or destroy with conventional methods. The Valtharians are already there, Danny continued. So are the Zephyrian Collective and the Thraxian Hive. All three species have sent their best engineering ships. Jake stood up. Ben set course for Kepler 442, maximum warp. Danny, send a message that we are coming to assist. Captain, Amy said quietly, what can we do that 3 advanced alien civilizations cannot? Their technology is centuries ahead of ours. Maybe that is exactly the problem, Jake replied. Lisa, start thinking about how we would handle a 50-kilometer asteroid with our equipment. As the Meridian jumped to warp speed, Lisa gathered her engineering team in the workshop. The room was filled with spare parts, tools, and half-finished projects. It looked nothing like the elegant biocrystalline systems they had seen on Nexus Prime. Okay people, Lisa said to her team of 6 engineers. We have 18 hours to figure out how to move or destroy a massive asteroid that is giving the galaxy's best civilizations trouble. Kate Williams, her senior mechanical specialist, looked at the asteroid data on her tablet. 50 kilometers of exotic matter. That is a lot of mass to move. What exactly is exotic matter? Asked Roy Anderson, the team's electronics expert. Amy's voice came through the workshop speakers. Exotic matter has unusual properties that interfere with most forms of energy. Biocrystalline systems have particular trouble with it because the exotic radiation disrupts their living processes. But it would not affect our mechanical systems, Lisa realized. Our circuits and machines do not have living processes to disrupt. Kate nodded. Right. And if we cannot move the whole asteroid, maybe we can break it into smaller pieces that will burn up in the planet's atmosphere. How do we break up 50 kilometers of solid rock? Roy asked. Lisa smiled. The same way humans have been breaking up rocks for thousands of years. We drill holes and put explosives in them. You want to use chemical explosives against exotic matter? Kate asked in surprise. Why not? Explosives are just controlled chemical reactions. They do not care what kind of matter they are exploding. Roy pulled up technical specifications on his console. We have nuclear charges in our weapons locker, much more powerful than chemical explosives. And we have mechanical drilling equipment. In cargo hold 3, Kate added. Left over from that mining survey we did last year. Lisa felt excitement building in her chest. This might actually work. We build simple mechanical probes with drills and nuclear charges, send them to key structural points on the asteroid and blow it apart from the inside. The aliens will think we are crazy, Roy said with a grin. Let them think that, Lisa replied. Sometimes crazy is exactly what works. Over the next 6 hours, the engineering team worked without rest. They took apart mining equipment and rebuilt it into space-worthy probes. Each probe was simple, a mechanical drill powered by a small reactor, guidance systems using basic radar and cameras, and a nuclear charge with a timer. No biosystems, no quantum processors, no adaptive crystals, Lisa told Jake as she showed him the finished probes. Just mechanical parts doing mechanical jobs. Jake examined one of the devices. It looked crude compared to the elegant alien technology they had seen, but it was solid and functional. Will it work in the exotic matter environment? It should. Mechanical systems do not care about exotic radiation. A drill bit is a drill bit, and an explosive is an explosive. As the Meridian dropped out of warp in the Kepler 442 system, they could see the massive asteroid ahead of them. It was dark and irregular, tumbling slowly through space toward the blue planet below. 3 alien fleets surrounded the asteroid. Jake could see the beautiful bioships of the Zephyrians, the crystalline vessels of the Valtharians, and the geometric craft of the Thraxian hive. All of them were trying different approaches to destroy or redirect the massive object. Danny, open a channel to the fleet coordinators, Jake ordered. This is Captain Morrison of the human ship Meridian. We are here to assist with the asteroid problem. The response came from multiple alien voices at once, all expressing surprise that humans had come to help with such an advanced engineering challenge. Captain Morrison, came Zixthera's familiar crystal voice. Your species has only recently achieved spaceflight. This problem requires the most sophisticated technology available. Maybe, Jake replied. But sometimes the best solution is the simplest one. Request permission to deploy our equipment. There was a long pause before the alien coordinator replied. Permission granted, Captain. But please do not interfere with our operations. Jake smiled as he watched the alien ships continue their complex attempts to solve the problem. Lisa launched the probes. The scene around the massive asteroid was chaos. Jake watched from the Meridian's bridge as dozens of alien ships tried desperately to save the planet below. The asteroid called Worldkiller continued its slow tumble toward the blue-green world, now less than 60 hours from impact. Captain, the Zephyrian bioships are having serious problems, Amy reported from her science station. The exotic radiation from the asteroid is making their living holes sick. Several ships have already pulled back for medical treatment. On the main screen, Jake could see the beautiful organic vessels of the Zephyrian collective. Their ships looked like giant sea creatures with flowing tentacles and smooth curved holes. But now those graceful forms were covered in dark patches where the living tissue was dying. The Valtharian crystal ships are not doing much better, Ben added. Their biocrystalline matrices are fracturing under the exotic energy. They keep having to rotate fresh ships into position. Danny looked up from his communications console. Captain, I am getting reports that the Thraxian mechanical constructs are losing hive mind synchronization. The exotic matter is interfering with their quantum communication links. Jake shook his head as he watched the alien fleets struggle. The Thraxians had sent massive geometric ships that moved in perfect coordination, controlled by their hive mind intelligence. But now the ships were drifting apart, their connection broken by the strange radiation. What about our probes? Jake asked. Lisa's voice came through the intercom from the engineering deck. All 12 probes are functioning perfectly, Captain. The exotic radiation is not affecting our mechanical systems at all. On the tactical display, Jake could see the small human probes moving steadily toward the asteroid. They looked tiny compared to the massive alien vessels, like insects next to elephants. But unlike the struggling alien ships, the human probes continued their mission without any problems. Pete, what is our target analysis? Jake asked his tactical officer. Lieutenant Commander Pete Johnson studied his console. I have identified 17 critical structural points on the asteroid. If we can place charges at these locations and detonate them simultaneously, the asteroid should break into pieces small enough to burn up in the planet's atmosphere. How long until the probes reach their positions? 6 hours for the farthest probe. Captain Jake nodded and turned to watch the alien ships. A massive Zephyrian biovessel was attempting to use some kind of organic weapon against the asteroid. Streams of living energy flowed from the ship toward the dark rock, but the exotic matter absorbed the attack without any visible effect. Danny, patch me through to the fleet coordinators. Channel open, Captain. This is Captain Morrison. We are deploying precision charges to break up the asteroid. Recommend all ships move to safe distance. The response was immediate and skeptical. Zixthera's crystalline voice came through clearly. Captain Morrison, we appreciate your efforts, but simple explosives cannot affect exotic matter. We have already tried kinetic weapons and energy bombardment. The material absorbs all attacks. Have you tried drilling into it first? Jake asked. Was a long pause. Drilling? That is a very primitive approach. Our biocrystalline boring systems cannot penetrate exotic matter. Our mechanical drills seem to be working fine, Jake replied calmly. On the screen, they could see one of the human probes beginning its drilling operation. The simple mechanical drill bit spun steadily, boring into the dark surface of the asteroid. Exotic radiation swirled around the probe, but the machine continued working without any problems. Amy looked up from her science station with surprise. Captain, the probe is actually penetrating the exotic matter. The drill is cutting through at normal speed. Why are our drills working when their biosystems cannot? Ben asked. Because our drills are just spinning metal, Lisa explained over the intercom. They do not have any living processes or quantum systems for the exotic radiation to interfere with. They are too simple to be affected. Jake watched as more human probes reached their target points and began drilling. Each probe worked steadily, boring deep holes into the asteroid structure. The alien ships watched from a distance, their sophisticated sensors recording every detail. The Valtharians are sending technical queries, Danny reported. They want to know how our primitive drilling equipment can function in the exotic matter environment when their advanced biocrystalline systems cannot. Tell them it is because our equipment does not think, Jake replied. Sometimes that is an advantage. 4 hours later, all 12 probes had reached their drilling depth of 500 meters. The nuclear charges were armed and ready for simultaneous detonation. Jake could see the alien fleets positioned at what they considered safe distances. Captain, Amy said with concern, the alien ships are much farther away than necessary. I think they expect our explosives to have minimal effect. Maybe they are right, Pete admitted. We are using conventional nuclear weapons against exotic matter. The physics might be completely different. Only one way to find out, Jake said. Lisa, are all charges ready? All probes report ready, Captain. Nuclear devices are armed and synchronized for simultaneous detonation. Jake looked around his bridge at his crew. They had come up with this plan using nothing but simple mechanical engineering and basic physics. No biocrystalline matrices, no quantum processors, no adaptive systems. Just drills, explosives, and mathematics. Execute detonation sequence, he ordered. The main screen showed 12 bright flashes deep within the asteroid as the nuclear charges exploded simultaneously. For a moment, nothing seemed to happen. The massive rock continued its tumble toward the planet below, then cracks appeared on the asteroid's surface. Thin lines of light spread across the dark rock like a spiderweb. The exotic matter that had seemed so resistant to energy weapons began to fracture along the fault lines created by the mechanical drilling. It is working, Amy said in amazement. The internal explosions are propagating through the asteroid structure. The cracks grew wider and brighter. Chunks of rock began breaking away from the main body. Within minutes, the 50-kilometer asteroid was splitting into dozens of smaller pieces. All fragments are now less than 1 kilometer in diameter, Pete reported. They will burn up completely in the planet's atmosphere. Jake smiled as he watched the asteroid break apart. Around them, the alien fleets sat in stunned silence. Their sophisticated biotechnology had failed where simple human mechanical engineering had succeeded. Danny, open a channel to all ships, Jake ordered. Channel open, Captain. This is Captain Morrison. The asteroid threat has been neutralized. All fragments are now small enough to pose no danger to the planet. The response from the alien fleets was immediate chaos. Every ship seemed to be talking at once, demanding to know how the humans had succeeded where they had failed. Jake listened to the confused alien voices and smiled. Sometimes the best solution really was the simplest one. The alien fleet coordinators demanded an immediate meeting aboard the lead Valtharian vessel. Jake found himself in a massive crystal chamber, surrounded by representatives from the 3 most advanced civilizations in the galaxy, floated outside the transparent walls, sleek and elegant even in their damaged state. Zixtera stood at the center of the room, its crystalline form shifting through different colors as it spoke. Captain Morrison, you must explain how your primitive mechanical systems succeeded where our advanced biotechnology failed. Jake looked around at the assembled aliens. The Zephyrian representative was a flowing, jellyfish-like creature that pulsed with soft bioluminescence. The Thoraxian delegate appeared to be a geometric arrangement of metallic shapes that constantly rearranged themselves. All of them looked confused and slightly disturbed. Our systems are not primitive, Jake replied calmly. They are just different from yours. But you use dead metal and simple chemicals, the Zephyrian representative said in a voice like rushing water. How can lifeless machines succeed where living systems fail? Lisa stepped forward from behind Jake. That is exactly why they succeeded. Your biosystems are alive, which means they can be disrupted by exotic radiation. Our mechanical systems do not have living processes to interfere with. The Thoraxian delegate shifted its geometric pattern, but mechanical systems cannot adapt or evolve. They cannot repair themselves or optimize their performance. That is true, Lisa agreed. But they also cannot get sick, decide to evolve in the wrong direction, or spend energy maintaining their own life processes. Sometimes reliability is more important than adaptability. Zixtera's crystal form flickered through several colors. Are you suggesting that our biocrystalline technology is inferior to your crude mechanical systems? Not inferior, Jake said carefully, just different. Your technology is amazing for many purposes, but it has weaknesses that our technology does not have. Amy stepped up beside Lisa. Your living systems are constantly processing information and making decisions that makes them very smart, but it also makes them slow and energy intensive. Our digital computers are much simpler, but they can perform calculations much faster. Show them the comparison, Jake suggested. Amy pulled out her tablet and connected it to the chamber's display system. 2 sets of numbers appeared on the crystal walls around them. This is the energy efficiency comparison between your bioprocessors and our digital computers for basic mathematical operations, Amy explained. Your systems use approximately 50 times more energy to perform the same calculations. The alien representatives studied the numbers in silence. The comparison was devastating. Human mechanical systems were not just different from alien biotechnology, they were dramatically more efficient for basic tasks. But our systems are self-repairing, Zixtera protested. They can evolve and improve themselves over time. Ben Carter spoke up from his position near the navigation displays. How often do they actually need to self-repair, and how much energy do they spend maintaining that capability even when they do not need it? Also, Pete Johnson added, what happens when they repair themselves incorrectly or evolve in a direction you do not want? Our mechanical systems do exactly what we design them to do, every time. The Zephyrian representative pulsed brighter. But mechanical systems break down and become obsolete. So do biological systems, Lisa pointed out. And when our machines break, we can fix them quickly with spare parts. When your biosystems get sick or evolve wrong, how long does it take to correct the problem? There was a long, uncomfortable silence. Jake could see that the alien engineers were beginning to understand the implications of what had happened at the asteroid. Roy Anderson stepped forward with a tablet in his hands. May I show you something else? This is a comparison of response times between your adaptive systems and our mechanical systems. New data appeared on the crystal walls. When conditions change rapidly, like they did with the asteroid's trajectory, our mechanical systems can adjust instantly. Your biosystems need time to sense the change, process it, decide on a response, and then implement that response. The asteroid was moving too fast for biological adaptation, Kate Williams added. By the time your living systems could evolve a solution, the planet would have been destroyed. Zixtera's crystalline form had turned a deep blue color that Jake had learned meant confusion or distress. Are you saying that all advanced civilizations have made a fundamental error in our engineering philosophy? Not an error, Jake said diplomatically, just a choice. You chose to develop living technology because it seemed more elegant and sophisticated. But every choice has trade-offs. What trade-offs did humans make? The Thoraxian delegate asked. We gave up self-repair and adaptation for reliability and efficiency, Lisa explained. We chose predictable performance over intelligent systems. We decided that it was better to have machines that do exactly what we tell them than machines that think for themselves. Amy nodded. Human philosophy has always been about using the right tool for the job. Sometimes you need a sophisticated adaptive system. Sometimes you need a simple, reliable machine. But surely living systems are superior for complex tasks. Zixthera insisted. Are they? Pete asked. He activated his tactical display. Look at how we solved the asteroid problem. We used simple mathematics to calculate the best places to put explosives. We used mechanical drills to put them there. We used chemical reactions to break up the rock. Every step was simple and reliable. Your biosystems tried to use complex adaptive responses to a simple physics problem, Ben added. You were using advanced technology to solve a basic engineering challenge. The alien representatives looked at each other in what Jake interpreted as growing concern. They were beginning to realize that their entire technological philosophy might be flawed. Captain Morrison, the Zephyrian representative, said slowly, "Would you be willing to share your mechanical engineering techniques with our civilizations?" Jake looked at his crew. They had come here to help save a planet, but they had ended up challenging the fundamental assumptions of galactic civilization. "We would be happy to share," Jake replied. "But I think the real lesson here is not that our way is better than yours. The lesson is that different approaches work better for different problems." Lisa smiled. "Maybe the best solution is to combine both approaches. Use biosystems where adaptation and self-repair are important. Use mechanical systems where reliability and efficiency are more important. Hybrid technology," Amy added. "Living systems working together with mechanical systems, each doing what they do best." Zixthara's crystal form slowly changed to a brighter, clearer color. "This would require us to rethink everything we know about proper engineering." "Sometimes," Jake said with a smile, "rethinking everything is exactly what you need to do." 3 months after the asteroid incident, Jake stood in a completely different kind of engineering lab. The room was aboard Nexus Prime, but it looked nothing like the flowing crystal chambers he had seen before. Half the space was filled with traditional Valtharian biocrystalline equipment, while the other half contained human mechanical tools and computers. Lisa worked at a bench in the center of the room, carefully connecting a human circuit board to a Valtharian crystal matrix. Sparks of light flowed between the two systems as they synchronized their operations. "How is the integration going?" Jake asked. "Better than I expected," Lisa replied without looking up from her work. "The crystal matrix handles the adaptive processing while our circuits manage the basic computational work. The crystal only uses energy when it needs to adapt to new conditions." Zixthara approached from the biocrystalline side of the lab. The alien engineer had spent weeks learning to use human tools, and its crystalline fingers now moved confidently with screwdrivers and wire strippers. "The hybrid system is 60% more efficient than pure biocrystalline technology," Zixthara reported, "and it responds to changes 5 times faster than our traditional systems." Jake smiled as he watched alien and human engineers working side by side. The collaboration had begun immediately after the asteroid crisis, when representatives from all 3 alien civilizations had requested detailed information about human mechanical engineering. Amy walked over from a testing station, where she had been working with a Zephyrian engineer. The jellyfish-like alien floated in a tank of specialized fluid, its tentacles manipulating both human tools and its own bioorganic instruments. "Captain, we have some interesting results from the propulsion tests," Amy said. "The Zephyrian are incredibly efficient at converting energy, but they are slow to respond to navigation changes, and our mechanical thrusters are fast but waste a lot of energy," added the Zephyrian engineer in its flowing water voice. "So we combined them," Amy continued. "Biodrives for efficient long-distance travel and mechanical thrusters for quick maneuvering. The hybrid system gives us the best of both approaches." Pete Johnson looked up from a weapons testing station. "The same principle works for defensive systems, adaptive bioshields that can evolve to counter new threats, backed up by a mechanical armor that provides reliable protection while the biosystems adapt." Jake walked through the lab, observing the various hybrid projects. At one station, Kate Williams was working with a Thoraxian engineer to combine hive-mind coordination with mechanical backup systems. At another, Roy Anderson was integrating human computers with Valtharian quantum processors. "The most important discovery," Zixthara said as it joined Jake, "is that our civilizations made the same mistake in reverse directions." "What do you mean?" Jake asked. "You developed purely mechanical systems and ignored biological approaches. We developed purely biological systems and ignored mechanical approaches. Both philosophies were incomplete. Danny Brooks approached from the communications section of the lab. Captain, we are receiving reports from across the galaxy. Dozens of civilizations are requesting information about hybrid engineering techniques. Word travels fast, Jake observed. Faster than we expected, Amy agreed. The Stellar Engineering Council has declared the hybrid approach to be a new branch of galactic technology. They want to establish research centers on every major world. Lisa looked up from her work with excitement. Captain, you should see what we accomplished yesterday. We built a power generator that uses biocrystalline energy collection with mechanical distribution systems. It produces 3 times more usable power than either system alone. The key insight, Zixthera added, is that biological and mechanical systems have complementary strengths and weaknesses. Biosystems are excellent at complex processing and adaptation. Mechanical systems are excellent at simple, reliable operations. Jake nodded as he watched the bustling activity around him. So the solution is not to choose one approach over the other, but to use both approaches together. Exactly, Lisa said. Use biosystems for the tasks they do best and mechanical systems for the tasks they do best. Let each system handle what it is good at. A new voice joined the conversation. That is a very human way of thinking, said Dr. Vexeri, a Zephyrian research coordinator. Most species develop one technological approach and stick with it. Only humans seem comfortable using multiple different approaches at the same time. Why do you think that is? Zixthera asked with genuine curiosity. Jake thought about the question for a moment. Maybe because humans have always been tool users. We learned early in our history to use different tools for different jobs. A hammer for driving nails, a saw for cutting wood, a needle for sewing cloth. We never expected one tool to do everything. Your species has a saying, Amy added. When your only tool is a hammer, every problem looks like a nail. Humans learn to avoid that trap by always carrying multiple tools. And now you are teaching the galaxy to carry multiple tools, Pete observed. Over the following weeks, Jake watched as the hybrid engineering approach spread throughout the galactic community. The Valtharians began incorporating mechanical components into their crystal matrices. The Zephyrians added mechanical backup systems to their bioships. The Thraxians supplemented their hive mind networks with independent mechanical units. But the most dramatic change came from species that had been struggling with technological development. Civilizations that had been unable to master either biotechnology or advanced mechanical systems found that they could succeed by combining simple versions of both approaches. We may have started something bigger than we realized, Jake told Lisa as they watched a mixed-species engineering team work on a new hybrid starship design. The galaxy is not just learning new technology, Lisa replied. It is learning a new way of thinking about technology. Roy looked up from his workstation. Captain, the Galactic Engineering Council wants to establish a permanent research institute here on Nexus Prime. They want to call it the Soul Engineering Institute. Soul? Jake asked. After your home star, Zixthera explained. The institute would be dedicated to developing hybrid technologies that combine the best aspects of all engineering approaches. And they want you to run it, Amy added with a smile. Jake looked around at the lab full of human and alien engineers working together. What about the Meridian? The institute would need a mobile research platform, Pete suggested. A ship that could travel to different worlds and share hybrid engineering techniques. Besides, Kate added, someone needs to teach the galaxy how to use hammers and screwdrivers alongside their quantum bioprocessors. Jake laughed. I suppose someone does. Lisa, what do you think about running a Galactic Engineering Institute? Lisa grinned as she connected the final circuit in her hybrid device. The biocrystal matrix glowed brightly as it interfaced perfectly with the human computer system. I think, she said, that this is going to be very interesting work. 1 year later, Jake walked through the corridors of the Soul Engineering Institute and marveled at how much had changed. The halls of Nexus Prime now buzzed with activity from dozens of different species, all learning to combine their traditional technologies with approaches they had never considered before. He stopped at a classroom where young Valtharian engineers were learning to use basic hand tools. Their crystalline fingers moved awkwardly at first as they tried to operate screwdrivers and wrenches. But their instructor, Kate Williams, patiently showed them the proper techniques. Remember, Kate was saying, these tools may seem primitive, but they give you direct physical control over your work. Sometimes you need that precision and reliability that only mechanical systems can provide. One of the students raised a crystal appendage. But teacher Kate, Why do we need to learn such simple methods when we have quantum bioprocessors? Kate smiled. Because your quantum bioprocessors cannot drill holes in exotic matter or operate in higher radiation environments. But these simple, mechanical tools can work anywhere. Jake moved on to another classroom where Amy was teaching mixed species physics. The students included floating Zephyrians, geometric Thoraxians, crystalline Valtharians, and several species that Jake did not recognize. The key principle of hybrid engineering, Amy was explaining, is to match the tool to the task. Biosystems excel at complex, adaptive problems. Mechanical systems excel at simple, reliable operations. Digital systems excel at rapid calculations. The best solution uses all three approaches working together. A young Thoraxian student rearranged its geometric pattern to indicate a question. Professor Amy, how do we decide which system to use for each task? That is the art of engineering, Amy replied. You analyze the problem and choose the simplest approach that will work reliably. Sometimes that means using sophisticated biosystems. Sometimes it means using a hammer and nails. Jake continued his tour and found Lisa in the main research lab, working with a team of engineers from 6 different species. They were designing a new type of starship that incorporated the best features of every known technology. How is the project going? Jake asked. Amazingly well, Lisa replied. The ship will use Zephyrian biodrives for efficient interstellar travel, human mechanical thrusters for precise maneuvering, Valtharian crystal matrices for adaptive systems, and Thoraxian hive coordination for complex operations, and human digital computers for all the basic calculations, added Dr. Vexmari, a Zephyrian engineer who had become one of Lisa's closest collaborators. The hybrid approach is producing results none of us could achieve alone, said Zex, who now served as the Institute's co-director alongside Lisa. Jake examined the ship designs on the main display. The vessel looked unlike anything he had seen before. Combining the flowing organic lines of biotechnology with the clean geometric shapes of mechanical engineering. When will it be ready for testing? He asked. Next month, Lisa replied. And, Captain, we want you to command the maiden voyage. Danny approached from the communications center. Captain, we are receiving reports from all over the galaxy. Hybrid engineering is revolutionizing everything from agriculture to space construction. Give me some examples, Jake requested. The Centauri colonies are using biosoil combined with mechanical farming equipment to triple their crop yields. The asteroid belt mining operations are using hybrid systems that adapt to different ore types while maintaining reliable extraction rates. Even the transport networks are upgrading to bioadaptive traffic control with mechanical backup systems. Pete looked up from a tactical analysis station. The most interesting development is in planetary defense. Worlds are combining adaptive bioshields that can evolve to counter new threats with mechanical weapon systems that provide immediate response capability. The galaxy is becoming more resilient, Amy observed. Systems that use both biotechnology and mechanical technology are much harder to disable because you would need to find ways to counter both approaches simultaneously. Jake walked over to a display showing the current status of hybrid engineering adoption across known space. The map was filled with indicators showing successful implementations on hundreds of worlds. It is spreading faster than we anticipated, Zixthera noted. Species that had never met are sharing engineering techniques and learning from each other. That may be the most important result, Jake realized. Not just the technology, but the cooperation it is creating. Roy Anderson approached, with a tablet full of data. Captain, we have been analyzing the overall efficiency improvements from hybrid systems. On average, civilizations using hybrid approaches are seeing productivity increases of 200 to 400%. And that is just the beginning, Kate added as she joined them from her classroom. My students are already thinking of applications we never considered. They are not limited by the assumption that you have to choose one technological approach. What do you mean? Jake asked. Traditional engineering education teaches students to master one approach, either biotechnology or mechanical technology or quantum systems, but our students are learning all approaches from the beginning. They think in terms of combining solutions rather than choosing between them. Amy nodded enthusiastically. The next generation of engineers will see possibilities that none of us could imagine because they are not constrained by our historical limitations. Jake watched as a group of mixed-species students worked together on a project in the main lab. They moved seamlessly between biocrystals and mechanical tools, using whatever worked best for each part of their design. You know what I find most remarkable? he said to his assembled crew. A year ago, each species thought their way was the only correct way to build things. Now they are all working together and creating things that none of them could build alone. The galaxy is learning the lesson that humans learned long ago, Lisa observed, that the best solution is usually a combination of different approaches, not just one approach taken to an extreme. Danny received another communication and looked up with excitement. Captain, the Galactic Council has just announced that hybrid engineering techniques have become the new standard for all major construction projects. They are officially adopting human tool use philosophy as a core principle of galactic civilization. What does that mean exactly? Pete asked. It means, Zixera explained, that the galaxy has accepted the idea that different tools work best for different jobs. No single technology is expected to do everything anymore. Jake smiled as he looked around at his crew and their alien colleagues. They had come to help with one engineering problem and ended up changing how an entire galaxy thought about technology. Captain, Kate said with a grin. The Council also voted to adopt an official motto for all galactic engineering projects. What motto? Jake asked. Sometimes the simplest solution is the most ingenious, Kate replied. I like it, Jake said, but I think we should add something to it. What? Lisa asked. Sometimes the simplest solution is the most ingenious, but the best solution usually combines the simplest approaches from different fields. Amy laughed. That is very human thinking, Captain. Most species would try to make the motto shorter and more elegant. Maybe, Jake replied. But most species also thought that more advanced always meant better. Now they know that sometimes the best answer is to combine simple solutions in clever ways. As Jake prepared to leave for his evening meal, he paused at the Institute's main display. It showed a real-time map of hybrid engineering projects across the galaxy. Thousands of indicators blinked steadily, each one representing a world where alien civilizations were learning to use hammers alongside quantum computers, mechanical systems alongside biocrystals, and human practicality alongside alien sophistication. Galaxy would never be the same, and Jake thought that was probably a very good thing.